Hey everyone, Al here from Open Walnut, and today we will be doing SAO, an easy Linux machine from Hack the Box. So let's get it cracking. Let's start with the port scan. We will use Nabu. We will do Nabu sao.htp top ports full and map CLI. I believe I actually missed host flag. I believe it's H. Top ports full and map CLI and map SV SC, that is version scan and default script scan, and then we will do OA to output it in every format possible as nmap results. I believe I did a mistake somewhere. Oh yeah, it needs to be host and not H. Let's quickly correct that. And while the full port scan is running, let's quickly split the terminal and do a quick nmap scan here while waiting for the results. We will do top 100 ports and sao.htp. So here we have port 22 SSH opened and port 80 HTTP filtered. Does not give us much to work with. Let's take it up a notch and do top 1000 ports. Hopefully that will give us some more results. And here we have it. We have another port open. Let's try to find out what this port is. Or rather, what port is running on that service. This is taking a little bit. Not sure why, considering this took 2 seconds and this took 3.5. I guess we will wait for this. Let me split the terminal again. With Control-Shift-R. Need to remember that shortcut for next time. Oh, I guess we did not need this. We can close it. Control-Shift-E. It does not seem to recognize this port. Perhaps let's try to see if we can reach it with a web browser. HTTP sao.htp 55555. Okay, looks like it's some sort of website. And it seems to have some sort of a basket application. Here it seems like we need a master token to gain access to these baskets. Let's come back as we don't have any. Gives us a 404, basket not found. Not sure what's going on here, but let's go back. Again, 404, basket not found. Not sure if this is intentional or it's just a glitch, but let's go ahead and create a basket. So I guess when you create a basket, it also provides you with a token. Let's copy this token. Actually, quickly, let's see. Seems like these are the only two ports, SSH and this web application. So I will assume that this web application is our way in one sense or another. Let me open a notepad so I can save this token. I wonder, so the basket is empty, send requests. And they will appear here. What else? Looks like we can do some sort of forwarding. That's just a refresh. Process body as HTML template. What is this? Share basket. Let's copy to your clipboard. Let's see. And the token seems to be included in get method. Not sure if it's relevant. Delete requests. So far I fail to see anything. Maybe let's look through let's look through the source code. Maybe there will be some sort of clue here. Looks like a lot of the code for application is right here. I'm just quickly glancing. Let's search for master token. Looks like there's only one mention of it right here. Let's use Vaporizer to see if that will give us anything. Doesn't look like it. Perhaps let's inspect home page, see if it's different than the basket. Oh, here it seems like we have software name. Hold up, let me zoom that in. All right, here seems like we have software name. Perhaps let's try and look that up. And here we have what looks like to be vulnerability. Let's check out GitHub. The repository contains proof of concept POC for CVE 2023-27-16-3. The server-side request forgery SSRF vulnerability is discovered in request baskets up to version 1.2.1. Let me just double check the version. Yep, it's 1.2.1. This vulnerability allows attackers to access network resources and sensitive information by exploiting the API basket's name component through a crafted API request. Request basket is a web application built to collect and register requests on a specific route, so-called basket. When creating it, the user can specify another server to forward the request. The issue here is that the user can specify unintended services such as network-closed applications. For example, let's suppose that the server hosts request baskets port 55555 and a Flask web server on port 8000. The Flask is also configured to only interact with localhost. By creating a basket which forwards localhost 8000, the attacker can access the before restricted Flask web server. Let's look at the screenshot just to see how this is done. As you remember earlier, we found a filtered port 80, so perhaps with this we can get to that port and see if there is anything there. So let's download the exploit. Let me collapse one of the terminals. Just gonna download the exploit. Let's quickly, actually, you know what? Let's quickly go through it here. Here it just looks like it gives the help arguments and telling you how to use the exploit. URL, attacker server. Basket name. API URL. Basket name. Payload. Yep. Doesn't look like it does anything rather than what description said, so I think it's safe to use. Always analyze exploits you download from the internet to make sure it is actually what the authors make them out to be, or at least to the best of your ability. Otherwise, just look for stuff that is vetted by the community. Don't just use random things without first having an idea of what they do. So let's do bash CVE. So here we will do bash CVE http south.htb 55555, and then we will do 127.0.0.1, which automatically should give us port 80. So it seems like the basket was created. Let's see what it gives us. So here we have another application, which seems to be some sort of security application, judging by these boxes. So we have a login function. Let's see if we can use this to get to it. Oh, login failed. So it seems like we have a way to proxy to this application through our server-side request forgery vulnerability. Let's let me open developer console quick and see how this request looks like. It just looks like it gives us 401 status, which is not authorized. Okay, I guess we have the version and the name of the application. So let's get to Googling. And as soon as we type it in, we have remote code execution exploit. Weaponized exploit for mail trail version v0.53, unauthenticated OS command injection. So unauthenticated pretty much means that we do not need credentials to perform this. So this Python script exploits a command injection vulnerability in the mail 053 web server 0. So the vulnerability exists in the login page and can be exploited via the username parameter. In this specific case, the username parameter of the login page doesn't properly sanitize the input, allowing the attacker to inject OS commands. The service uses the subprocess check output function to execute a shell command that logs the user name provided by the user. If an attacker provides a specifically crafted username, they can inject arbitrary shell commands that will be executed on the server. In the shell scripting, the semicolon is used to separate multiple commands. So when the attacker provides a username that includes a semicolon, followed by a shell command, the shell treats everything after the semicolon as a separate command. Basically, everything after semicolon will run anyway. Exploit overview. The exploit creates a reverse shell payload encoded in base 64 to bypass potential protections like WAF, IPS, IDS, and delivers it to the target URL using curl command. The payload is executed on the target system, establishing a reverse shell connection back to the attacker's specified IP and port. The script requires 3 arguments: the IP address, where the reverse shell should connect back to, the listening IP, the port number on which the reverse shell should connect, and the URL on the target system. Perfect. Let's look over the script quick again. This looks like one of those Python one-liners from Pentest Monkey. And then it looks like it encodes the payload and then sends it through curl. Again, looks like a pretty straightforward exploit. Let's grab the link for that. And let's download it. I guess if we want to reverse shell, we actually, you know what, I'm going to work in the same window. We can use netcat to listen on port 8000, and we'll do Python 3 exploit. Let's see what was target URL. Let's grab my IP quick. $8,000, and target URL will be copy link address, paste. And it looks like we got our reverse shell. Let's upgrade our terminal. Import pty. That should summon sudo terminal for us. pty.spawn, and we'll do bin bash. Probably Python 3. Import pty.spawn bin bash. Who am I? Puma ID Puma cat etc password grep. Here I just want to see who has login rights, and it just looks like there are 2 users, which is root and Puma. Here we have our user.txt file. And I usually start by doing sudo privileges to see if I can get any privilege escalation. That's typically my first go-to on these CTF boxes, and it works about 6 out of 10 times, I would say. Let's see how we can privilege escalate with this. privilege escalation. And note that here it says we do not need a password to execute this. So, for example, let's do sudo terminal is not fully functional. We just executed sudo. If you can execute as root, we can spawn another shell in the pager. Just run the command with sudo, then enter the following in the pager like less. Sure. So let's do bash. And we got root. cd root ls cd root, and here we have our root flag. And that is it, folks. That was a pretty easy box. To sum it up, we had a vulnerable service, a vulnerable web service running on port 55,555. That it was vulnerable to server-side request forgery. We then used server-side request forgery to obtain an internal service running on port 80. The internal service was vulnerable to remote code execution, which we used to obtain the shell. Once we obtained the shell, we used sudo list privileges to see if the user has any, if the user can run any commands with sudo. We found out that the user can run system control status trail.service as sudo, and we ran that, and then we escaped from the output using exclamation mark bash, which spawned the shell for us, and we got root. Thank you for watching the video. Hopefully you guys enjoyed it, and see you next time.